Hey, what's up, everybody? Today I want to talk about some organic chemistry, and specifically I want to talk about making esters. And the synthesis I'm going to do today is going to be based on an alcohol and acetic acid. So we're just going to use a general alcohol formula, where R could be any size aliphatic chain. So butanol, propanol, whatever. And here's acetic acid. This is also going to be in the reaction. And this is catalyzed with a strong acid like H2SO4. To give you a nice ester. And where R is the same R up here, just any size group you're going to want to leave on there. Okay, so let's go through the synthesis. First, what happens is your acetic acid is actually protonated at the carbonyl by your stronger acid. So we have some H2SO4 that made some hydronium ion. Right, and what's going to happen is that is going to protonate, and you're going to get some water. So now we have this as our first intermediate. And the positive charge is conserved, and it's on here now. This is followed by an attack of the alcohol. And that double bond is going to push up here, so you don't have 5 bonds in that carbon. And now our positive charge is going to move to this one. So let's draw our next intermediate. Right there. And there's our alcohol that we started with. Just kind of jumped on that carbon back there. Okay. And don't forget our other final alcohol. It's that one. Just carried it down here. What will happen next is one of these alcohols, these hydroxyl groups, is going to come down here and grab one of these, and that charge is going to shift over there to the other one. So now what happened is, if you can see, we still have one hydroxyl group, and then we have this, where the positive charge in hydrogen just switched over to another hydroxyl group, and it left our with our ester that just formed. And that's going to make an excellent leaving group. So what we're going to happen is we're going to see these have some electrons on them. That's going to jump down here and it's going to force this one off. And our positive charge is going to move up here for conservation of charge sake. So check this out. We got a carbonyl right here, and there is our ester. But remember, this carbonyl is protonated and it has a positive charge on it, plus the water that we just lost. And so because remember the acid is just a catalyst, this H2SO4, we created some water up here, another water is going to come and deprotonate this. And then we used up a hydronium ion and we created a hydronium ion at the very end. So you can see that's going to come and grab that. And that's going to pop back onto here. And then there will be no charge on our ester. So that will be the final product right here. Plus the hydronium ion that we started with from the H2SO4. And that has how you do an ester. And you might have noticed, I just realized this when I was drawing it, that was from a book. That should actually be CH3 the way I started, and then you're going to have an R there. So if you just go through, see the acid. The acetic acid is used up as reactant, your alcohol is used up as a reactant, and your strong acid is used in a catalytic amount. So let's say, for instance, that you started with isopentyl alcohol, and isopentyl alcohol is just another alcohol, and it looks like this. So you can see there's 1, 2, 3, 4, 5 carbons, hence the pentyl. And it's iso just because it's not in a straight chain. So this would be our R group. That's the start of the R. And basically that whole thing is the R. So our product formed would look like this. And this side over here is just the acetic acid core that we started with. And then here's our ester. This is where it starts. And here's our isopentyl group. Or isopentyl alcohol. That was what it started as. Okay. CH3 and just another CH3. So there we are, that's how you form an ester. And another name for this product would be isopentyl acetate, because we started with acetic acid. That would be the acetate right there. And there's our isopentyl group. So, alright, see you guys next time.